Hi guys, I hope you're good. I hope you're well and excited for our lesson today. We are still doing exponents, but we are looking specifically at set expressions and focusing more on the addition and subtraction of sets. So grab your pen and paper because there's a number of notes that you'll have to take on this lesson. So guys, we have previously discussed that the laws of exponents can also be extended to include rational numbers. So we need to include rational numbers when extending the laws of exponents, and a rational number is any number that can be written as a fraction. So we can write a rational number as a fraction with an integer. So we need an integer in the numerator and also the denominator. And in this lesson, we look at simplifying said expression under addition and subtraction. So one important thing that I saw that you guys need to really know about is when adding and subtracting sets, we need to also take note of like and unlike sets. So let's go back. Algebra, the first part of it. Like terms. So when you had to choose, you had x plus y and you have x and x, you had x and x, and you need to tell me which ones are like terms and which ones are unlike terms. So x plus y means you have unlike terms. So it means these two they're not of the same family. But if I have x plus x, I simply know that I have these ones from the same family. The same thing occurs with sets, guys. If you have the square root of 2 plus the square root of 3, these are not like sets, so they are unlike sets. But then if you have the square root of 2 plus 3 root 2, these are of the same family because on this first one, there's an imaginary one there. There's a 1, always an invisible one actually. So you can easily say your answer is 4 root 2. But the first one, we couldn't simplify because the root, the values that are there, they're not of the same family. So it also works with also having, you need to have the same value underneath and also the same value there. So if it's a square root, it should be square root for both, and also the value of a must always be the same. Now, applying these laws, and since that you understand what like sets and unlike sets are, let's try to do this example. It says they simplify the square root of 147 plus the square root of 108. First look at it, you're like, okay, we have square roots both sides. Yay, good news. But then 147 and 108, they don't look the same or similar in any way. Now it's time you bring up your math. Learning back how to break down numbers. You need to break down numbers in this part. So let's try to break down 147 use to its simplest form. For example, if I want to break down 4, I can write 4 as 2 times 2. So let's try to use that method here and see if it works out for us. So guys, if you check on your calculator or if you're trying to check all the factors of 147, you will come across something like 49 times 3. Because the moment you say 49 times 3, you actually get 147. You can use a calculator, check it, it works. And also 108 can be written as the square root of 36 times 3. So if you have 36 times 3, you still manage to get 108. Now, we are not done because we tried to get a common number both sides. But here's what's more interesting. So if you have 49 can be written as 7 times 7. So it's 7 times 7 to the power of 2, this is times 3, plus the square root of 36 also is a perfect square, so it can be written as 6 to the power of 2 times 3. Now there's a law that says if you have the square root of a times the square root of b, you can easily write one square root and say you have a times b. Now, in this problem, we have things as square root of a times b, but we need to reverse it. So it means we're moving from this side, going back there. So we're moving from this square root to the other one. So now, what you have to do is simply say you have the square root of 7 squared times the square root of 3. So I'm breaking down this first square root. And plus the square root of 6 squared times the square root of 3. Now, if you break down the square root of 7 squared, you're just going to get 7. So now this becomes 7 root 3 plus what is 36? What is 6 to the power of 2? The square root of 6 to the power of 2 is 6, and you're left with the root of 3. Now, what's more interesting is you got yourself like sets there, easy. So if you have like sets, you can easily add the numbers next to them. So I'm just going to add 7 plus 6. So it means my final answer will be, so if I add 7 plus 6, I'm getting 13. So we're choosing that. So this will be root 3. So how you treat these values is the same way you will treat in normal algebra when you're solving for x. So if you had just take this as, let's just take this value as 7x plus 6x. So your answer becomes 13x because you have like terms there as x. So the same thing happened here where we had like sets. So root 3 was the set that appeared both sides. So that is why we got our answer as 13 root 3. So guys, that is how you simplify this one. And let's see if we have one more so that we can try and do it and see how we're going to get our answers. So I suggest you try it on your own first before checking the answers that we have here. So guys, solving this one, you use the same technique that we used on the previous example, where if you have a value that you think you can break down such that it looks like the other one, so you can try to break down 20. So if I want to write 20 and it including a 5, I will say this is the square root of 4 times 5, because 4 times 5 gives me a 20, so I'm still okay. And this is minus the square root of 5. We can't break that down any further, so we just leave it that way. And this is the same as the square root of 4 times the square root of 5 minus the square root of 5 all squared. Now the square root of 4, guys, is given by 2. So this is 2 root 5 minus root 5 all squared still. And this will be, what is 2? There is a 1 there, so what is 2 minus 1? It's going to be a 1. So you're simply left with root 5 all squared. And if that is the case, the square root of 5 squared is given by 5, because this squared kills the square root today. So that is how you solve this problem. So try to break down numbers using their factors if you can. Bring down all the factors that will be favorable for you, because you have to look at the next number. Okay, so make sure that you look at the next number and then you can try to break down factors using that number as a reference. So guys, thank you for joining me on this lesson, and I will definitely see you on the next one.